Hi there, cyberspace cadets! We're thrilled to have you back for another exciting episode. Today, we're exploring the wonderful world of robotics and discovering the incredible things they can do. So, meet Jovani Gittens, the president of Harrison's College's Robotics Club in Barbados. Beyond his role as president, Jovani possesses a passion for the world of robotics. His exceptional knowledge and proficiency in building robots using ordinary household items are second to none. Gigabit Kids is excited to share his extensive expertise with you as he guides us through the process of constructing your very own bot. Then we jump to camp, Science in Motion 101. We had the pleasure of speaking with Gregory Grisette, a robotics tutor and educator. While he teaches high school in Louisville, Kentucky during the year, he spends his summers in Barbados, imparting knowledge to young digital enthusiasts. Also, during the episode, we showcased the Miss 2023 Science and Technology Festival in Barbados, where students from West Stars Primary School impress us with their robot building skills. Additionally, we introduced Miss Maureen Pollard, a tutor from the Barbados Community College, who enlightens us about their latest robotics program. So stay logged on as we start this bot building adventure. Take it away, Jovani.
Okay, so let's talk a little bit about what actually makes a robot a robot. So you have to have these different characteristics: a brain, sensory organs, a body or skeleton, and muscles. So in the case of the brain, you have what is called the microcontroller and microprocessor. Those are the things that does the thinking for the robot. Then you have sensory organs. Those are called sensors. So coming to this robot here, this here is a sensor. It receives data from the world around it, and it allows the brain to use that data to make decisions. Then you have the body. The body of the robot is the actual frame, what holds it together. That's why we said that it was also like the skeleton. Stops everything from falling apart, gives it structure. And then the muscles. The muscles are just the things that make things move on the robot. The actuators, for example, motors, these things here are attached to the wheels that spin. So these motors on the bottom, you can see those are like muscles. You put electricity through it and they move. So when a machine has all of these characteristics, the ability to think with a brain, the ability to sense its environment with sensory organs or sensors, a body or skeleton, a frame to hold it together, or muscles, things to move and interact with the environment, then it's classified as a robot. So before you get building the robot and using tools to put things together, you have to remember to be safe. Nobody likes to get shocked or nobody likes to hurt themselves. So that's why we have equipment like this. These are eye goggles. They protect your eyes. So when you put them on, if anything were to fly up and hit you in the face, it would never actually hurt your eyes. It's very important to protect soft tissue like eyes. Then you have these gloves. So these are gloves that I would wear when I'm using different tools. For example, a hammer, a saw. And when you put them on, if you were to accidentally hit yourself, then you wouldn't have to worry about breaking bones. It reduces the chances that you're going to be seriously injured. Now, you must remember that although you have these personal protective equipment or PPE, you still have to exercise caution. So you can't run around with a knife just because you have on a vest. You can't play with electricity just because you have on rubber gloves. You have to remember to always think of safety when you're building these robots. Now coming back to this robot here, you see that it also has a frame or a body of sorts. The thing that actually holds all the electrical components together. In this case, it would be a plastic container. Now this is actually a food container. I chose to do that to show that you could really take anything and make a robot. It's not something that you have to go to university to start, or that you have to spend thousands and thousands of dollars just to do a little bit and do some tinkering. No, anything that you have at home, for example, a food container, you can use to do robotics. Now this is plastic, so it's reusable. So it's not going to break down. It allows me to hold all the components together without fearing for if it is waterproof, because I know that it is, it's plastic. And it's also very strong, so I can drop this and nothing should break. So this is an ideal material for what I'm using. So it's a car that I'm using it for. Then we have these motors with the wheels attached to them. These are actually the motors right here. So you see that metal part, they're housed within this plastic. And the motors just take electricity and turn it into movement, or kinetic energy is what we call it. So when you put electricity through these wires, you see again the red wire for positive, black wire for negative, put electricity through it, and it turns the motor, which then turns the wheel. That's how we get the robot to actually move. Again, looking in, you see another microcontroller with its microprocessors and the different pins that have the electricity. You see wires, you see the LEDs, and you see some other components that I wouldn't have talked about before. This here, in case you can see, let me move the wires out of the way. This is called a MOSFET. It's almost like a switch, or really it is a switch, an electronic switch. So you have switches in your house which you normally have to flip manually. What that does is it turns off and on a circuit. This allows you to do it with electricity.
Hi, my name is Gregory Grisette, and I'm here at the Barbados Museum doing the robotics section of a camp, Science in Motion 101. I've been teaching robotics in Louisville, Kentucky for the past 15 years. I've been living there for 20 years now, but I'm a Barbadian returning home ever so often to give back to the community and to share with the youngsters the exciting work that there is in robotics. So there's tremendous scope for the development of coding and robotics in Barbados. And I think that we're on the right track in introducing it to schools and starting from very young. What we have to remember though is that the whole aim, in my view, is to develop problem solvers and critical thinkers. Not every child would become an engineer, but every child can be a problem solver or a critical thinker, and we need that in every profession. So my own thinking is that if we continue to encourage coding and robotics, the sky is the limit, or beyond the sky is the limit now, really. We expose them to robots, different kinds of robots, different ways that robots help to solve problems. And then as they work together, they see solutions being realized, and that's very important. So I would encourage parents to just let your children explore robotics. I know that the school system is already trying to get that done, but if you push them in that direction, you're not trying to get them into a sciencey thing or a mathy thing. You're trying to get them into a problem-solving thing, and that's very, very important for what we do in life. It is a life skill. If you solve problems, you solve problems in your relationships, in your work, and wherever, and you need to just encourage children to do that now. All right, so what the students had to do during the camp is learn to build and program the Lego Mindstorm EV3 to perform a series of tasks. And then I presented them with a map of the area right opposite government headquarters on Bay Street. And what we've done, we've created a scenario where there has been a hurricane and some things are out of place. We are going to offer help using the robots. So their task, which Prime Minister Motley stepped out of her office and said, I hear that you guys are great at robotics and you're good at coding. We want you to use your knowledge and your robots to help us clean up this mess. All right, so The robot starts in a specific area, and there are a few tasks. In front of me is a group of people who are stranded. They need help. So the robot will take a little dinghy or Moses, whichever we want to call it, and deliver it to these people so that they may be rescued because it's flooded in this area. We use the robot instead of a human because we are aware that fallen power lines could prove dangerous if you are walking in water. They do conduct electricity. Sadly, the bust for Sir Grantley Adams has been toppled, and we want to get that back up. So the robot will have to find a way. They will add a piece to the robot to bring it right back up to an upright position. The biggest challenge for them is this boat, maybe the HMBS, whatever the Defense Force boat is called, has been washed out of the sea onto the sand. So the robot will then come and push the boat back into the water. Other tasks include sending supplies to the ambulance because that's the hospital there on Beckles Road. So you send supplies to the ambulance. There's debris on the road, so you clear the road of the debris and so on. So this is where they get to look at how hurricanes affect us and how robotics can help with the cleanup after a hurricane. It's very exciting, and I'm seeing a lot of very good teamwork and good collaboration.
Hi, I'm here with Demar Brown, a general science teacher at West Terrace Primary School, and he's here with some of his students today, and they're demonstrating what they're doing with robotics at West Terrace Primary School. So just tell us a bit about what you do, what you teach, and what your kids are into.
Hi, good morning. My name is Demar Brown, and I teach general science at the West Terrace Primary, and we are here with our robotics program. It is generally about integrating students into technology, and we use VEX Go, and we have VEX 1, 2, 3. And we basically build them using the kits, and we use the instructions online to get the applications built. And then afterwards, we use our tablets to then code them where they can perform various actions. We have crawlers, we have some that can drive, they perform actions, they can pick up objects, and they identify colors right below them.
So tell me a bit about what West Terrace is doing generally to cultivate an interest in STEM in their students.
Well, to cultivate STEM, we mainly focus on the robotics because that's what we have at hand. So we have an education system where we stay back on the evening, say on Fridays, and we go from 3:30 to 4:30, where the students are engaged in robotics activities.
Okay, is it optional or is it compulsory that they have to learn at least one aspect of STEM topics?
At this stage, it's optional, and we will give out letters, and then the parents to decide if students show interest if they can get permission to stay back after school. So it's optional.
Okay, when was this initiative first conceptualized?
Well, it's been running for, I would say, 3 weeks. Yeah,
they've been all this in 3 weeks.
That's what it is.
I was here thinking this is something that's been going on for a couple of years. Okay, that's pretty amazing. And what would you say the reception has been like with the kids?
It was great. The children love it. They're interested and eager to learn. I asked them if they want to take a break after the event, the exhibit is over. They said, no, sir, we want to continue doing it.
Okay, that's good. So that means they're involved, they're having fun. Okay, perfect. So what we're going to do now, we're going to have a chat with one of our students, Joshua. She built a little robot, so you can tell us a bit about that.
This is a competition, advanced competition clock. I built it in about 20 minutes.
Wow.
First, you
Was
would
that your first time building it?
no, please.
Okay.
First, you would have to build the competition advance, and then you have to look at a different instructions to complete it before clock. And I like robotics because it's very fun. I get to express myself with building
Do you see this being something you might be interested in?
Yes,
Okay. And what do you think is the possibility of all this technology for you as a kid now and when you're older?
to help me learn,
It can help you.
learn new things. I could get to express myself.
Okay, which is very important. All right, so thank you so much for telling us what you're doing today. We appreciate you taking the time to do that. And we're very pleased to see what the youth of Barbados is doing. Thank you. Thank you.
So this robot is actually meant to follow walls. The idea is that if you had a factory or maybe a maze, you would be able to actually use this paired with the different sensors it has, the controller or brain, to write code which can follow that wall and get from point A to point B. That way you don't need to see where you're going, the robot sees for you. Okay, so let's talk a little bit about the different components within that robot. Right, so here we have some LEDs. LED actually stands for light emitting diode. The way that it works, you have electricity that goes through here and there's a filament inside, which when electricity goes through produces white light. Now this outside, this housing that's plastic, it has different colors. So you see this one is red, this one is green. Now when that white light shines through the housing, only these colors are shown. The wavelengths of light that are red or that are green is what's let out. Then you have this diode. Now this diode is much like a door. It only allows electricity to go through one way. So we often hook it up in a circuit so that electricity can always go from where we want the positive to be to where we want the negative to be. It will never work if it goes the other way because, as I said, you can only open this door in one direction. Now these wires link everything together. So you use these wires to hook up the different components. For example, hooking this diode to the LED, you would use these wires. Now all they are really are just metal strips inside of a rubber or plastic installation. That just means that it stops electricity from going through it. So when you touch this, even if it was hooked up to a battery, you wouldn't get shocked. It's only if you touch this metal part that electricity could come through. So we have the microcontroller, or the brain of the robot. Now what I just mean by brain is the thing that controls everything. So you write code to this, and again, code is just ones and zeros, but we write it in C++ in this case. This is an Arduino. So you write a C++, that's just a programming language. It changes it to ones and zeros, whatever you write, changes it to ones and zeros, and it uploads it onto the board. And those ones and zeros hold instructions for the robot. For example, turn on the LED, turn it off, turn on a motor, or turn it off. Now, this microcontroller, if you can see, has this microprocessor. That is kind of the thing that does the real thinking. That's where these ones and zeros are, and that's where the calculations are. And then you have these pins, what we call pins. These are where wires go. So electricity actually flows through these different pins depending on what you want, or rather depending on what the microprocessor tells it to do. And then we have a battery. So this is just a normal 9-volt battery that you get from a store. I have it hooked onto some wires here. This connector has the 2 wires. This red wire is a positive wire. Now, when I was talking about the wires, you would have seen that we had some light wires and some dark wires. So this here is a blue wire, a dark wire. This is a lighter wire. Now, similar here, you see a light wire, so red, and then a dark one, so black. That's because we normally have the dark wires representing negative and the lighter wires representing positive. And black and red are the most common ones. So this battery just holds electricity. Everything in the circuit, whether it be the LEDs or the motors, even the microcontroller, uses electricity to work. This just stores that electricity, and when we want it, we can hook it up to the circuit or hook it up to the different components so that we can get that electricity to really work. Let's talk a little bit about this component that we see here. Now remember I said that this robot was meant to follow a wall? Well, the way that it does that is to know the distance away from that wall and to stay the same distance whilst driving forward. And we can calculate that distance using this component here. This is an ultrasonic distance sensor. The way that it works is it produces sound which bounces off of a wall, and then it can measure the echo, or rather the time that it takes for that sound to get back to the microcontroller. You can then do some math and work out what distance away the object was. Let's talk a little bit about how this works. You have this speaker which is outputting sound, and you see those sound waves here, and those go all the way until they hit an object. Now once sound hits the object, it tends to reflect or bounce back, and then you have this microphone here that when that sound bounces back, it picks it up and it can tell that there is sound coming into the microphone. So then if you have a timer, some sort of clock in the system where you can see the time that it took for the sound to get from here, the speaker, to the wall and then back, you can actually do a calculation using the speed of sound and the time that it took to find the distance. Right, and the last component of the robot, which really and truly is the most important component, is what I'm using to hook everything together without the need for wires. This is called a breadboard. So just to show you that the breadboard is this white thing underneath, you see all the wires and the LEDs, MOSFET, diode, all connected on this white thing. That white thing is the breadboard. And the way that it works is almost like a group of wires that are put together. So let's draw that out. It's a rectangle. And you have these two things called rails. That's where the majority of the electricity goes through. You put power to those rails, and you have a positive rail and a negative rail. I would often hook up a battery to these rails. And then you have these rows or columns, which also are connected. Now notice that there's no particular positive or negative column or row. It's just there. And really and truly what it is a connection where everything in those rows operate at the same voltage. So if I apply 5 volts to, let's say, this row right here, everything there, if I hook up a resistor, if I hook up a lamp, everything that's hooked up to this row is going to be at 5 volts. Similarly, if I do the same here but with 3 volts, then whatever I hook up here, whether it be a lamp, a resistor, it'll all be operating at 3 volts.
My name is Maureen Pollard. I am a tutor at the Barbados Community College in the Division of Computer Studies. Today we are here to showcase the programs of the community college in this area. We have our traditional programs which deal specifically in preparing people to be, for example, hardware technicians. So we do courses in hardware, we have courses in programming, and we have courses in website development. But one of our latest courses is the certificate in robotics. So today we are featuring that particular course. So today for the exhibition, we first of all are showcasing some of the top robots that exist. This is your end position where we want Barbados to be, right? Robots that are used in movies, robots that are used in industry, etc. And then we are showing how the process evolves. At the beginning of the class, you are given a kit, and this kit is the VEX kit. As you can see, the kit comes with just very basic parts. And your first job is to design the robot. So you start with the basic kits there, which would have the robot's wheels, the arms, etc. Then, excuse me, little one. So I'll show you what you do. You start with the kits. These are all the parts. You're seeing the wheels, etc. Right? And then you build the frame, and you have to make sure that the frame is sturdy. The wheels are not wobbling or anything like that. This is a robot. So in the class, you learn how to build your robots first, right? And after you build the robot, you're going to put this on. What do you think this is? What do you think this? What do you think this is?
What do you think that is?
Well, let's go back. What do you think this is? Going to grab things. So this is the claw, right?
You know, some things when you see on television, you see
Right. So
something
you have the arm here, and the arm has the claw already. Is this it?
There's the arm here. Come.
And then what do you think these are at the front? These are like the, hey, so this is the controller. Hold a minute, let's look at this. So these are the sensors. These will tell the robot where to go.
These are like the eyes of the robot.
Right, and this is the brain. You know how you have a brain?
Everybody has a brain in this?
Right, this is the brain of the robot. We saw a little girl yesterday. She was just 9, but she wants to be a scientist. And she was able to not only master controlling the robot, but she was also able to do the programming in one try. Right? So we have a lot of budding young scientists, and it really blesses your heart to see the young scientists and see how enthusiastic they are about this. So I think this is a very good experience for them, because they only hear about robots. But one child said to me yesterday, I didn't know robots were real and could do things, so at least they get a sense of how the robot works now. So I think that this is a good step for Barbados.
Meet TechBot. TechBot is our EV3 model, which we built a couple days ago on Monday, and now he's here, trying to help people during a post-hurricane model. This is a model of in front of government building. Now, here's what I learned this almost a week in coding. Firstly, coding is a lot of trial and error, but if you try really hard and you never give up, you eventually will get it. We do have one video which does show when we did get it, and boy did that feel good.